Hello, this video is about interest compounded. Let's begin with the first type of interest compounded. It is interest compounded continuously. Okay, so the formula is A equal P E R T. Okay, A is the amount after T years. P is the principal. E is an irrational number. Okay, E is just like pi. Okay, and R is the interest rate, and R will be written in decimal, and T is the number of years. So let's begin here. Julio invests $8,973 in a saving account with a fixed annual interest rate of 2% or 0.02 and compounded continuously. What will be the balance? So account balance after 8 years. So we have the principal, we have the rate. We want to find the account after 8 years. So A is what, and we have T. So we substitute now. So A equal 8,973 times E to the powers. So let's put right here 0.02 times 8 and put that in your calculator, and you will get the account balance after 8 years. So I show you the calculator. So let me clear. So I'm going to go ahead and put 8,973. E, to get E, you hit on the key second, and then ln, and then put the exponent 0.02 and times 8 and hit enter. So therefore after 8 years the account balance will be $10,529.91. Okay, so now go back and write out the answer. So the account balance after 8 years is $10,529.91. Okay, let's look at the next interest compounded. Okay, so I'm going to clear this and look at the next one. So in this case, Trevon invests $8,205. So this is the principal in a retirement account with a fixed annual interest rate of 4% or 0.04, compounded 6 times per year. So this will be not the one that we just learned. So let's go ahead and share the new formula with you. So this is interest compounded n times per year. So A equal P times 1 plus T fraction R over N to the power N times T. So in this case, this is our N. Our N is 6. And our T will be 13. So I'm using the formulas. So our principal is 8,205. 1 plus the interest is 0.04 in decimal divided by n. So again, what is n? N is the number of time interest is paid each year. Okay. And then to the powers 6 times 13. Okay. Now you go ahead and put this in your calculator. And that will give a $13,777.24. And if you need help with how to input in your calculator, I can show you now. So let me show you. So go to the calculator. Then I'll put the principal 8,205 times 1 plus, and if you have TI-84 with the new OS system, you can use the alpha y equal key to get into the fraction. If not, you don't have to do it. So I'll put 0.04 divided by 6, close the exponent, 6 times 13. Okay, yes, so this is how you get it. So I hope you feel okay with how to input the given expression in your calculators. Okay. So let's go ahead and go back to where we were. Okay, so the next example that I'm going to show you, we will use the compounded continuously formulas. So let me erase this. Then move on to the next one. Okay, so let's go ahead and read the problem together. So on one, invest 3,769, so that will be the principal, in a savings account with a fixed annual interest rate of 5% or 0.05, compounded continuously. So what are the formulas? So A equal PERT. How long? So we want to find T. We will take for the account balance to reach $4,839.49. So we give an A. Let's substitute all we know. So we know A is $4,839.49. P is 3,769. E is just an irrational number. R is 0.05, and we don't know T. So we want to find T. So the first thing so if you can see right here that we cannot put in the calculator directly right away. So this is an exponential equation. So the first step we have to do is that we need to isolate the base E with the exponent by itself. So I'm going to go ahead and divide both sides by 3,769. So that will give us 4,839.49 divided by 3,769 be equal E with the exponent. Okay, so that is the first step. And then the next step, you will say, what about next? How can we just take E away? Like, we don't want to see the base E. How can we cancel the base E? So now I'm going to go ahead and to cancel the base E, we have to use logarithmic. So I'm going to make a quick note for us right here. So this is our note to solve exponential equation. So let's say our exponential equation will be b to the x equal a. We should, so this is our advice for you, take the base b logarithm logarithm of each side. Okay, so what it means is that you go back to the given equation. You take log space b, and then copy down the rest. So I'm going to use two different color. So right here, I'm going to copy the b to the x, and then a. Okay, so that's it, what it means. Okay, so why we need to do that? Because if we take log base b of the given expression with b to the power x, and we cancel out, so that will just give you x. Okay, on the left hand side, of course, the right hand side with log base b of a. So that is what we should apply here. We want to cancel the base e, right? So we have to take log base e of both sides. Okay. So log base e, it would just the shortcut is just natural log. Okay, so I'm going to go ahead and take natural log. So again, natural log is the shortcut of log base e. So in this case, in the base is e, then log base e. So therefore, the right hand side will just give us 0.05 t. And then for the left hand side, you will put it in your calculator, and that will give you a number. Okay, so let me go to the calculator right now, and I'm going to put that in so you can see how to do it. So I'm going to go ahead and put ln, and then I'm going to put 4,839.49 divide by 3,769 and hit enter. So here we will end up with 0.249999629. So I mean, we shouldn't round the number yet, because this is not the end yet. So if you can write all of the number, that would be great. Now if you cannot round or if you don't want to write all of the number, but you want to write round, then can you help us? Can you round at least 3 number behind the decimal point? So in this case will be 0.250. Okay. So I'm going to go ahead and go back to our paper. 0.250. Okay. Now go ahead and solve for t. Then we conclude that our t, which is the number of years, that would be 0.250 divided by 0.05. Okay. So put in the calculator again. Let's go back to the calculator. 0.250 divided by 0.05. So that will give us 5 years. Okay. So our answer, it will take 5 years for our account to reach $4,839.49. Okay, thank you so much for watching this video. Goodbye.